Hello, my name is Adam. In this video we are going to learn how to make Flappy Bird in Unity. Flappy Bird is an infinite side-scroller where the player controls a bird attempting to fly between columns of green pipes without hitting them. If you need help at any point in the tutorial, feel free to join our Discord community where we can offer direct help. There's a link in the description of the video. Please consider subscribing to the channel to support the amount of effort it takes to create a video like this one. It is completely free, but it helps me a ton. Thank you. Enjoy the video. Let's begin by creating a new project using the Unity Hub. In the top right corner, we can click the new button to create a new project. We can also click the drop down next to it to select the specific version of Unity we want to use. For this tutorial, I will be using Unity 2019.4. It won't really matter though which version you use. We won't be using any special features that are available in one particular version of Unity. So really, feel free to use whatever version, but I will be using 2019.4. So we're going to select that. Here we want to choose the 2D template since this will be a 2D game. This is going to install various 2D packages that will help us in our development. Go ahead and name your project whatever you would like. I'm going to call mine Flappy Bird and choose wherever you would like to save your project and go ahead and click the create button. From here, it might take a couple of minutes to initialize, so we'll pick it up as soon as it's finished. Once your project finishes initializing, you should see something like this. By default, Unity provides us a sample scene that we can use to get started. I'm just going to simply rename this to Flappy Bird. And from here, we need to import some custom sprites that we'll use throughout our game. If you want to use the exact sprites I'll be using, you can download them from GitHub. There will be a link in the description of the video. That link will take you to the repo here. Look for this download link, and that will download the entire project. Within that project will be the assets folder and then the sprites folder, and this will contain all of the exact same sprites I'll be using. I definitely encourage you to use your own sprites though. Let me go ahead and just drag these files into my project here. Although first, let me create a folder to contain them all. This will just keep them nice and organized. So I'm just going to call this sprites. And let's go ahead and just drag in these files. And once these files are in our project, we can change various import settings on them. So for all of these sprites, one thing we want to change is our pixels per unit. All of these sprites were designed at 24 pixels per unit, so I'm going to set that to be 24. This of course might vary based on your sprites if you are using your own custom sprites. From here, I'm also going to change the format to RGBA 32-bit. I'm going to change the max size to 256 since none of these images are very large. And finally, this is pretty important, I want to change the filter mode from bilinear to point. This is going to really maintain the pixel style graphics that we want. So point there. Let's go ahead and apply all of these changes and we're good to go on our sprites now. Next, let's just do a little bit of scene setup before we begin scripting. So in the left here is our hierarchy where we can see all the game objects that exist in our scene. Right now there's just a camera. And on the right is our inspector where we can see the various components that exist on that game object. So for our camera component, I want to just simply change the background color. And actually, if we switch to our game view here, we can preview what our game looks like. Let me go ahead and change this background color to match our background sprite. So I specifically want to match just the blue part of it. And I can actually just use the little dropper tool, the eyedropper here, and then I can hover over that color and then we can set that exactly. We're actually going to hold off on adding our background and our ground to our scene because we're going to set them up a little bit differently to using a parallax effect. So we're going to focus on that specifically in a little bit. But for now, let's get our player in there, our bird. So we can actually just drag this sprite into our hierarchy here, and this will add it to our scene. We can see our bird show up there. And then from here, we just need to add a few different components to our bird here, to this game object. And first, I'm going to call this player, and I'm going to set the tag to be player. This tag should already exist as part of your project. It's one of the default tags Unity provides. This will allow us in our code later on to, reference this object by this tag or determine if some other object is indeed this particular object. From here, let's add some components. We can click add component and we're going to add a rigid body 2D. Since this is a 2D game, let's make sure we use the 2D version. And then we're going to change the body type to be kinematic. What a rigid body does is it turns this object into a physics object. So this is going to actually simulate physics on this object. However, by making it kinematic, it's not going to simulate the physics. It's not going to change the position or anything. However, the reason why we still need this component is because without it, we can't detect collisions between our object and other objects. So we need a rigid body, but we're going to be moving the bird manually through its transform. So we're going to set it to kinematic. And then from here, I want to also add a collider. Specifically, I'm going to use a circle collider, although it doesn't really matter, but I find this circle collider kind of works best. And if we go to our scene view here, if I scroll in, you can see the green outline here is the actual area of the collider. And our collider, what that does is it defines the collision area of this object. So one thing I kind of want to do is make it a little bit smaller. So I'm actually going to just change the radius here to maybe 0.25. And yeah, that works actually pretty perfectly. So that's it really for our bird. And that's all the scene setup we're going to do for now. Like I said, we're going to focus on some of the other elements later. But let's go ahead and start scripting our bird. All right, let's create our first script. Although let me create a folder that will contain all of our scripts, just to once again keep everything organized. Within this folder, I'm going to right click, create C# script, and I'm just going to call this player. Once that script has been created, we can drag it onto our player game object. So we can drag it here, put it into the empty space at the bottom, and this will now execute the script as part of this game object. Go ahead and edit this. So by default, Unity creates a class that inherits from mono behavior. Personally, I like to delete these functions they provide by default and some of these imports that aren't used. Just my preference there. So for our player, we need to declare a couple variables that we'll use throughout the class here. One is going to be our direction. So let's make this, we can make this private actually, not public. So private vector3 direction here. And then let's also create a public float, and we'll call this gravity. So this will allow us to customize how much gravity we want to apply on the bird, which you might use to change how difficult the game is. And I can default this to maybe 9.8 or negative 9.8, since that's what real life is. If you notice here, with that being public, if we go to our script in the editor, we will see that one show up. Only the public variables though, which is really convenient. And this allows us to customize that value in our editor. So from here, let's add our update function. Update is a function that Unity calls automatically every single frame this script is running. And usually this is where we handle things like input. So in update, let's go ahead and handle input. What we can do is add an if statement that says if input dot get key down, and we can look for a specific key in our keyboard. So for example, I could do spacebar. Every time you press spacebar, we will like flap or kind of fly upwards. Or I could say if input get mouse button down, and then you have to provide an index here. 0 would be your left click. So in this case, I'm saying you can either press spacebar or you can press the left mouse click, and this will kind of flap the bird. And so when we do this, we want to set our direction to be up, vector3.up. And we actually might want to multiply that by some strength. And once again, that could be another variable we use to kind of dictate how difficult the game is. Let's go ahead and add that. I have another public float here. I'm going to call it strength, and maybe I'll default it to 5. So here we can say vector3.up times strength, and we're good there. Now, considering this is a mobile game, or the original game is a mobile game, you might want to test for touch input. And so let me show you how to do that, although I won't be able to actually fully test it out because I don't have all my mobile set up. But if we want to handle touch inputs, we can say if input.touch count is greater than 0. So this is letting you know how many fingers essentially are touching the screen. And if it's more than 1, we can go ahead and get a reference to that particular touch object. So we can say touch equals input.getTouch, and then we provide the index here. We're just gonna only get the first one. We don't really care about the others, although maybe for your game you do. With this touch here, we can check if it just began, if it just ended, if it's currently active, things like that. So for example, I might want to say if touch.phase equals touchphase.began. So this is essentially saying I just touched the screen. I just began touching the screen with some finger. And then from here, we'd probably do the exact same thing we're doing above. So essentially, it's like you tapping. Potentially, this might vary based on your implementation. Maybe you want to do it when it ends instead of began. It can all vary, but play around. That's kind of the gist, the very, very basic way you can do some touch input. And then from here, our input is good now, but we always need to make sure we're actually applying gravity to the direction. So this direction only gets set to up when we actually activate our input, but every other frame you're not actually activating the input, we always want to be applying gravity, or every frame, no matter what, we always want to apply gravity. So we can say direction, specifically just the y-axis. We only care about gravity along the y-axis. So we can say direction.y plus equals gravity, and then times time.delta time. Let me explain what this is going to do, but let me write one more line of code first. Now that we have our direction, we just need to update the position of our bird. And to do that, we're going to access the transform of this object, and we can say position and then plus equals direction. So we're updating the position of our transform based on their direction. And we also want to apply the times this by delta time. This is going to make it frame rate independent. So no matter what the frame rate of your game is, whether you're running at 60 frames a second or 1 million frames a second, it's going to be consistent. Now you might be wondering, why are we timesing by delta time twice? Well, that's because gravity is an acceleration. It's meters per second squared. And so we, specifically for gravity, we actually want to multiply it both times. And so that's really it for our player. Let's go ahead and test this out. We can see our variables there. Those are good. Let's go ahead and just run our game. So by default, I fall down because of gravity. And if I click or press spacebar, I flap back up. Perfect. So this is working great. And once again, you can customize these values to potentially change the difficulty of the game. Let's actually animate our bird now when it moves, when it flaps. So let's go ahead and go back to our player script here. And to animate it, we just need to change the sprite that is currently being displayed and just kind of cycle between a few different sprites. So to change the sprite, we're going to need an access to the sprite renderer component, because the sprite renderer component defines the actual sprites, as we can see here in the editor. Let's go ahead and declare a variable for that. We can just call this, and we'll make this private. We're going to call this sprite renderer. And we can assign this value in our awake function here. Awake is called automatically by Unity the very first frame this object, essentially when this object is initialized, and it will only get called once per the whole life cycle of this script. So here we can say sprite render equals get component, and we specify the type of component we want to get, which is sprite render. What this is going to do is it's going to search for that component on the same object that this script is running on, right? So our player here, our player game object has our player script. And so when you get component, it's going to look for these other components and see if it matches the one you specified. And then from there, we need to define an array of sprites that we can actually cycle between. So this we'll make public because we'll define what those sprites are in our editor. And we're going to make this an array using our square brackets there. And I'm just going to call this sprites. And lastly, we need one more variable to keep track of the current index in this array. So this will be an integer, and we can just call this sprite index. All right, so from here, when our script first starts, we need to start kind of the animation. So Unity has another function that's called automatically, called start. This will get called the very first frame that this object is enabled. And when we start here, we can use invoke repeating. Invoke is a way of calling another function, and in this case, repeating. So it's going to repeatedly call that function over and over again. Although we need to define what that function is first. So let me actually create a function here. I'm just going to call this animate sprite. And let's go back up here. So we need to pass in the name of the function. So I can use the name of keyword, and I can say animate sprite. And then we need to provide the time, like how often do we want this to repeat? Or this is the initial one and then the repeat rate, but I'm just gonna use the same for both of these. And let's say it cycles every, 1.5 seconds or something. And you can obviously adjust that to your liking. So this is gonna call our function down here every 0.15 seconds. And so within here, we can increase the index and then reassign the sprites on our sprite render based on whatever index in our array. So that's what I'm gonna do. I'm gonna say sprite index plus plus. That's just gonna increment it by 1. And then we need to make sure it loops back to the beginning if we get to the very end of the array. So we can say if sprite index is greater than or equal to sprites.length, then we can set it back to 0 to start over. And then finally, we just need to update our sprite. So we can say sprite render dot sprite equals, and then we're going to access our array here. We're going to use a subscript operator to then get the sprite at this index. And that's really it. We just need to now assign those sprites in our editor. So let's click our player game object. We can see our sprites here. If we go to our sprites folder, there, in my case, I have 3 sprites. So I'm going to set our size to be 3. And I'm just going to drag in each of these. 1, 2, and 3. Let's go ahead and run this and see what happens. Here we go. So now we kind of are flapping, and it makes a lot more sense. It looks like we're actually moving properly this time. Next, let's add our background elements. And this is going to really make everything come together and especially make the player feel like they're moving. Now remember, in a side scroller, the player's transform left and right isn't actually changing. The background is moving, and that's giving the illusion that the player is moving forward. So go ahead and add our background elements. Now, however, we're not going to just drag in our background to our scene because this is going to create a sprite renderer. We're going to actually do this a little bit differently in order to create a parallax effect. And to there'll be an easier way we can get the background to move kind of infinitely using a different approach rather than a sprite render. So I'm actually going to right click in our hierarchy. I'm going to go to 3D object, and that's okay. Even though this is a 2D game, we can still create 3D objects. And I'm going to create a quad. Now a quad really is more of a 2D object, but they're used commonly in 3D games. I'm going to reset the transform here to its default, so we can use the little 3-dot menu there. And a quad will allow us to render a texture on this, on this quad here. But to do that, we need to create a material. So if we go, well, let me first create a folder for our materials. So it's folder materials, once again, just keeping everything organized. Let's open that up, and let's right click, create material. I'm going to call this background. And from here, any material, you can specify the shader that is used to render this material. In our case, we just want to render a texture. So we can go to unlit texture, and this is going to change the properties that are available for us. Mostly we just want this texture here. So we can go to our sprites, we can drag in our background, and boom, now we have a material with our background on it, and we can preview that down here. We can go back to our quad object, and we can drag our material onto it. You can actually just drag it into this empty space or into the materials slot here. Now we can see our background. Obviously it's really small because it's not sized correctly, but we'll get there. One thing we should do is remove this mesh collider. Our background does not need a collider. We don't need our bird colliding with the background element there. So let's get rid of that. And let's go ahead and size this properly. So for your game, I don't know if you're developing it for mobile, for tablets, for desktop. It doesn't really matter, but you can preview your game using whatever particular aspect ratio you want to. So right now I'm using 16:9, which is more of a desktop aspect ratio. Maybe you want to do more like a phone. or a tablet, whatever you want to do, it doesn't matter. We just want to make sure that our background can cover the entire space. So I'm going to set my scale to be 24. And that'll just make sure it's big enough to really cover the space here. So we can see the white outline is our camera, and very much it covers it. It goes past it, and that's perfectly fine. And then I want to set our Y scale to be 10.6666 repeating. And that's because that's just going to maintain a specific aspect ratio to this particular image. So it's just going to maintain it exactly. It doesn't really matter if it were to stretch a little bit, and obviously it could vary if you're using your own sprites, but just once again, make it large enough that it fits and fills up the entire space. Now, obviously it actually is stretching right now, and that's because we need to actually tile this, and this material lets us change the tiling properties on it. So I can say tile it by 4, and this will basically display the one image 4 times. Now it still looks really messed up, and that's because we need to change a particular import setting on our on this file here. So we select our background sprite. Let's change the wrap mode to repeat. And we apply that, and now you can see our image repeats. And we should do the same exact thing for our ground here, because we're going to be repeating this process for that object too. So let's change our ground. So this looks perfect. It fills the entire space. It repeats 4 times. Everything's good. And then we can write a little script that will simply cycle the offset here. See, if I change this manually, I can just change this forever. It'll just go on forever because it repeats and it loops back. And so what we can do is write a script that changes this, and this is going to make it seem as though we're moving. So for now, I'm going to set that back to 0. And let me rename this object to be background quad, just make it a little bit more meaningful. Let's go ahead and write that script. Go to our scripts folder. I'm going to right click, create C# scripts. I'm going to call this Parallax. Let's go ahead and add this script to our backgrounds. We'll drag that on. Let's go ahead and edit this. And for our script here, we just need to essentially get a reference to the mesh renderer. So the mesh renderer, kind of like we did for our player, we got a reference to the sprite renderer because we changed the sprite property. In our case, we need to change the material, and you access the material through this mesh renderer component. So we need to get a reference to that. So very similar to what we did on our player, we can declare a variable here for mesh renderer, call this mesh renderer. In our awake function, we can get component of that particular type. And then in our update function, we can change the offset on the material repeatedly. So update, we can say mesh render dot material dot main texture offset plus equals, and then some new, this is a vector 2, so we're going to form a new vector 2, and we just need to set this to be, whatever we want. We should probably declare a variable that'll allow us to customize the speed that it moves. So we can have a public float here, call this maybe animation speed. I'm just going to default it to 1. And so here we can say animation speed. Once again, we're in times by delta time because we want it to be frame rate independent. And then we'll set this to 0. For the Y, we don't care about the Y. We're not moving it in the Y. We're only moving it in the X. And that's actually all we need. Let's go ahead and test this out. Let's play this. Obviously my character fell. It's obviously a little bit too fast. So let me go ahead and change it. We can go to our background. I'm just going to make this way smaller. Let's do 0.05. And let's play it again. That's a lot better. Now, this is a background element. It's really, really far away from the player. And so it should be moving much slower. But now let's go ahead and add our ground. And our ground, you'll notice, will be a lot faster because it's closer to the camera. And this is going to create the parallax effect. The difference in speed between the background element and the foreground element creates this parallaxing effect. So let's sort of repeat the same process. Let's go to right click on our hierarchy, 3D object, quad. Let's call this ground. I'm going to reset the transform. I'm going to remove the mesh collider. And let's create a new material. Oops, not a lens flare. That's not what I want. Create material. Call this ground. We're going to change the shader to unlit texture. We can go ahead and select our ground texture there. There's our material we're seeing the preview of. We can tile this one by 4 as well. It'll be the same amount. And let's go ahead and add this material to our ground mesh renderer here. And let's see what else. We need to change the scale of our object. So I'm going to do 24 to match the background. And this one only needs to be scaled 2 in the Y. And you can see this orange outline, but it's actually behind the background when it needs to be in front of it. So what we can do is actually change the Z position. This is going to change the draw order that they get rendered in. So we're going to make that -1. The lower the number, it gets drawn first, or I guess last, but yeah. So -1 there. Now it's in front, which is what we want. And let's go ahead and position this towards the bottom. Let's say -4.5. That looks perfect. Let's see what it looks like from our camera's perspective. Yeah, that looks great. And we can just add that exact same sprite that we already added. Or not sprite, the script. So parallax script. And like I said, the speed will be bigger, will be much larger in this case since it's closer. We'll just keep it at 1 and see what it feels like. Yeah, that actually honestly feels great. It actually feels like I'm moving and flying now with the ground moving. The background moves too, but it's much slower because it's a lot farther away. And that is a really nice parallax effect. Okay, let's start focusing on our pipes now. The first thing you want to do is create a prefab for our pipes because we're going to be repeatedly spawning new pipes. And so we need some prefab that we can use to kind of clone that object over and over again. So let's go ahead and create a folder for our prefabs as we've done for all of our other asset types. And let's just start creating our pipes in the scene, and then we can drag that into our folder here, and that will turn it into a prefab. So for our pipes, it's actually going to be a collection of 2 pipes. There are going to be the top pipe and the bottom type, and that's going to be treated as one kind of game object. So we can just create an empty game object in our hierarchy. I'm going to reset the transform here. Let me switch to our scene view. And from here, we can create children objects. Let's find our pipe sprite and let's drag that in, and we're going to drag it over our game object here. And this, now you can see it's parented to that. I should probably call this too. I should probably call this pipes. So we've got 1 pipe, which is great. And let's duplicate this. I can press Control D or Command D, or you can also right click and do duplicate. And so we've got 2 pipes. Right now they're sitting on top of each other. We just need to position them kind of respectively. So let's put one maybe 4.5, and the other will be the exact opposite. So -4.5. And this creates a little gap between them. The one at the top needs to get flipped around. So let's go to that one. We can just simply rotate it on the x-axis to flip it around. That looks great. Now this gap in between is going to really play a pretty big factor in how difficult your game is. So feel free to adjust this distance to your preference. I'm going to rename these both to be pipe, or I can say, top and bottom, just so it's a little bit clear what's what. Now, one thing we need to do is we need to add a box collider to each of the pipes. The collider will allow us to detect when our bird actually runs into the pipe, and that will cause a game over. Let's add a box collider to this, 2D, and we're going to mark it as a trigger. We don't actually really need to simulate the real physics of it. We just need to know, hey, the bird has entered into this area. So that's what a trigger will allow us to do. Same thing on the bottom, add component, box collider, 2D. And you'll notice that it changes the size automatically based on the sprite, which is really convenient. And then finally, we actually want one more little trigger zone right in between, because that's going to tell us, hey, we should increase the score. They kind of flew through it successfully. Boom, give them another point. So we can create an empty game object as another child of this. I'm just going to call this like scoring or something. I'm not really sure what to call it. We'll just call it scoring. And it's just going to have a box collider on there. 2D, of course. We'll mark it as a trigger. We don't actually want the bird to fly into it. We just want to know when they've entered this zone so we can give them a point. And we'll make it a little bit bigger so we can change the size of our box collider. We'll make it fit within that gap. And then I might make the X a little bit smaller just so, you know, they have to kind of cross at least sort of halfway between before they actually earn their points. That looks pretty good. You know what? I'll make the Y just a little bit bigger just in case. It doesn't matter if it overlaps because they will run into the pipe before they run into the little scoring zone here. So that's it for our prefab. Let's actually turn it into a prefab now. We just take this game object and we drag it into our scene here. Or not into our scene, sorry, into our project panel, and now it's an actual prefab. And now that we've done that, we don't actually need to have this object in the scene. We can delete it now. We have the asset, and we'll use this to then spawn it repeatedly in code. Okay, let's create our spawner script that we can use to repeatedly spawn pipes that the player will have to obviously avoid. Go to our scripts folder, right click, create C# script. I'm just going to call this spawner. Let's open this up. Just like I usually do, I'm going to delete all these things. And let's think about how we want to spawn this. So what are some of the variables we're going to need? One, we're going to need a reference to the prefab so we can spawn that object over and over again. We also might want to define some variables for how often the pipes spawn. And we might want some variables to change the position of the pipes and maybe like a range between some min and max. So it'll kind of randomize where within there it will spawn. So let's create a variable for our prefab. We're just going to reference this as a game object. We'll call that prefab. Let's create a variable for our spawn rate, and this will be a float because it's going to be the amount of seconds. And let's just default this to 1. Let's create 2 more variables now to kind of define a range that will position the pipes either up or down. So we can maybe call this min height, and then maybe that's -1, and then we can do max height, and this can maybe be +1. Okay, and then from here, very similar to what we did in our player, we're going to do this invoke repeating. So although we're not going to do it on start, we're going to do it on enable. And that's because at some point we're going to disable the spawner. You know, for example, if the player loses, we want to disable the spawner, kind of stop everything. And so we want to only start repeating, like do the spawning repeatedly when this spawner script is actually enabled. So here we can do invoke repeating. We need to provide the method, which we don't have yet. So let's go ahead and create that. I'm just going to call this spawn. And then we can pass the name of that function to our invoke repeating. We have to give it our time here. Our time is our spawn rate that we declared. Same thing here. We'll just pass that twice. And then let's do on disable. We need to cancel this so it stops spawning. So on disable, we can say cancel invoke and then name of spawn. And by the way, both on enable and on disable are Unity events that are called automatically whenever this script is enabled or disabled. You can enable or disable a script via this checkbox here. So when you know, or that's how you would do it in the editor. You can obviously also do it programmatically, which we will be at some point. But that little checkbox is setting it to be enabled or disabled. So in our actual spawn function, we need to clone our prefab. We can say game object, we can say pipes, and we can say instantiate. This allows us to create a new object, and it's going to clone an existing one. So we're cloning our prefab, and then we're getting a new set of pipes here. So we can say prefab, we can give it an initial position and rotation. So the position should just be wherever the spawner is positioned. You can move the spawner anywhere in the scene, and that's where they will spawn at. So we can just say transform that position, just referencing the spawner's position. And then same thing here, we can pass in the rotation. They don't need to be rotated at all. So we can just say quaternion.identity is essentially no rotation. And then finally, we want to adjust the position of the pipes either up or down based on a random variable between these. So we can say pipes.transform.position plus equals up times then a random value within a range. So we can use Unity's random class, and we can provide a min and a max here. So this is our min height and max height. And this will now position the objects up or down. And since this could be negative, if you do up times a negative value, that would actually be down. So up or down between some random value in our range there. And that's really it for our spawner script. Let's go ahead and test this out. Although we need to actually create our spawner game object in our scene. So let's go ahead and right click, create an empty object here. I'm gonna call this spawner. And we just need to position this. For now, I'm gonna reset the transform, and let's just position this off to the side here. So let's maybe set the X to be 12. Actually, yeah, it actually would perfectly. If you remember, our background and everything was set to 24, so we're kind of doing it halfway. It's right on the edge of our map there. And let's add our script to it. We need to make sure we're assigning our prefabs. We can go to our prefabs assets here and drag that in, and we're good there. And let's go ahead and run this and see what happens. Okay, so you can see on the left, we have our pipes spawning, but of course they're not moving because we haven't written the code to do that. But we at least have them spawning repeatedly, so that's a good start. All right, let's focus on getting our pipes to actually move across the screen. So let's go ahead and create a new C# script. I'm gonna right click, create C# script. I'm gonna call this pipes. And let me add this to our prefabs. Let's go to prefabs, let's select our asset there, and let's drag our pipes script onto it. Let's go ahead and start editing this. So for our pipes here, all we really need is a speed variable, and then in our update function, we will move the position of our object. So we can say public float speed. I'm going to default this to 5, and we're making this public so we can customize it in the editor. Once again, this is a way you can change the difficulty of your game. Let's add our update function here. And we just got to say transform.position plus equals vector3.left times our speed times delta time, which will make it frame rate independent. So it is consistently moving regardless of the frame rate. And then the other thing we want to do is we should destroy the pipes as soon as they're off the screen. We no longer need them. So we can detect if the position has exceeded some value and then just destroy the pipes. Now, we could easily just hard code some number and that would probably be fine, but it's bad practice to do that. So let me show you how we can do this better. Let's create a variable that is going to represent the left edge of our screen. And then here, we'll assign this value, but here we can say if our transform.position.x is less than the left edge, then we will destroy our game object. Destroy our pipes in this case. Now, how do we assign this value? So we can calculate that actually pretty easily. Let's add our start function. We don't need to calculate it every single frame. We only really need to calculate it once. So we'll do that in start. And we need to convert screen space coordinates to world space coordinates. Our transform is always in world space, or our, well, not always, but specifically here, our position, it even says, is world space position. But we want to say whenever our pipes are past the edge of the screen, whatever that is, whether you're on mobile, tablet, desktop, we don't care what the screen size is. We just need to know that it's past that edge of the screen. We will destroy. So we need to convert from screen space to world space. And you do that by accessing your camera, and then there's a function you can call. So we can say left edge equals camera.main. Camera.main is gonna find the game object, or the camera that is tagged main camera. And then we can say screen to world point. So this is converting from screen space to world space. So we need to provide a screen space position here. So our left edge is just 0, actually. it's just 0. So it makes it easy. So we can just say vector 3.0. And in this case, we're getting an entire vector back. We only care about the x-axis, so we can just say .x. Now there's one issue with this, which is that when we, let me show you, if we bring our pipes into the scene here, our pipe, the position of our pipes and most game objects is centered around, or it's pivoted around the center point here. So as soon as our object, the center of it hits the edge, it will get destroyed. But we're gonna see them kind of vanish before they're actually fully off the screen. So we want to just offset that position a little bit more to make sure that our pipes are fully going off the screen before they get destroyed. So let's go back to our script real quick. And all we simply need to do is just subtract 1 from this position. So we're just pushing it 1 unit further, and that'll give us enough space to make sure it goes fully off the screen. I suppose that depends on how big your pipes are, but 1 unit in most cases should be good, but potentially you might need to adjust that. And so that's it for our pipes. Let's go ahead and test this out. Let's go ahead, and we added our script to, my thing's all bugged. So let me pause real quick and come back because my interface got all bugged. 1 second. Okay, I've relaunched Unity. Interface is no longer bugged. I don't know what happened there. But let's go ahead and just run our game and see that this works. And once again, our pipes script is part of our prefab. We're good there. Speed is 5. I'm just going to watch from a scene perspective, so our pipes are moving. As soon as they cross that threshold, boom, they disappear, get destroyed. From the perspective of the game, it looks great. So perfect. This is working absolutely perfectly. All right, let's start to tie everything together by adding scoring and, of course, actually running into the obstacles and getting a game over. So first, let's create a script that's just gonna kind of manage the overall state of our game. And I usually like to call this our game manager. So let's create a script called game manager. And I usually just have this on a standalone object in our scene. So we can create an empty object. We can call this game manager. I'm gonna reset the transform here, although it doesn't really matter. We're gonna drag that script onto our object there. Let's go ahead and edit this. So for one, we need a score variable, and I'm gonna make this private because it isn't something we need to change in the editor. And then let's create a couple functions here. So for one, I want maybe an increase score function, which will simply increase our score by 1. And later on, when we add UI, we'll add another line of code here to update our UI. But for now, that's all we're going to do. And let's also add another function called maybe just game over. And this will obviously get called when you run into something. And when you run into something, we'll have to, we'll display a menu and so on to start the game over. We're going to do that separately, but let's just get the functions in place. And maybe for now, we'll just debug. We'll just say game over. We just want to know that this is being called. We'll worry about everything that happens in a little bit. So how do we detect these two different things? So one, we need to know when our bird crosses over the little scoring zone in our pipes here. And we also want to know when they hit a pipe itself or the ground. If they just fall and hit the ground, that also is a game over. So what we can do is we can tag some of these game objects, and then we can detect, or we can know which object our bird has run into. So let's go ahead and open up our pipes prefab. We can set our tag here. Right now these are untagged. Let's add some custom ones. Let's click the plus button. Let's add one for obstacle, and let's add one for scoring. And let's go back to our top and bottom pipes will both be obstacles. We set those to be obstacles, and then our scoring zone will be set to scoring. And then we also just want to label our ground as an obstacle. I know it's not like really an obstacle, but we're just going to pretend anything that's an obstacle means if you hit it, you lose. And anything that's marked as scoring means you gain score. So now that those are tagged, in our player script, we can detect collision between the bird and whatever other object. And we can do this by using the function onTriggerEnter2D. If you remember, we marked those objects as triggers because we don't actually care about the physics simulation. So they're just triggers. They're 2D, the 2D versions of them. And then this takes one parameter here, which is collider 2D. And usually people call this other. It's the other collider you have run into. And from here, we can check what is the tag of this object. And if it's either obstacle or scoring, we can call the respective function in our game manager. So we can say if other.gameObject.tag equals, let's say, obstacle, well, then we will call to our game manager. Now we need to get a reference to our game manager. And one way we can do this is using find object of type, and we can say game manager. This is going to search our entire scene for that object. This is actually not the best function to use. It just depends, but this can be a very costly function. It's very expensive to use this. For our game here, since this is just happening in one, it's not happening every single frame or anything like that, we're fine. And our game as a whole is very, very simple, so we don't really need to get too picky about our performance optimizations here. But just keep in mind, this isn't always the best function to use. There are better ways to do this. They're just a little bit more advanced and complex, and it's just not worth going over right now. So find object of type game manager, and we can then call our game over function. Now we can't because they're private. So let's go ahead and go back to these and make both of these public. That way we can access them externally. So now we can actually call game over. And then same thing here, but this time instead of the tag being an obstacle, the tag will be scoring, I believe we called it. And if it's scoring, then we will say game manager dot increase score. Okay, let's go ahead and test out this code. We've added it there. Let's go ahead and test. I'm gonna open our console here so we can see that debug statement. So since we don't have any UI yet, I don't know if I'm actually gaining any points, but let me run into a pipe there. And so no, nothing happened. I didn't actually hit the pipe. So there is a problem here. Let's take a look at our pipes and let's make sure we have those colliders on them. We do. They are triggers. So that's good. Oh, our bottom, we forgot to mark the bottom one as a trigger. So that was a mistake. Let's test that again. Let's run it. We should see a debug statement. Yeah, so they're game over when I hit, yeah, so now if I hit the top, I get a game over. If I hit the bottom, I get a game over. And let's see if we hit the ground, I should also get a game over, which I do. Now, one way we can test if our score is increasing, we can go to our game manager. We can click this little 3-dot menu next to the inspector and go to debug. And this will allow us to see some of those private variables. So we can see our score is 6. Our score is actually increasing as we go through the middle here. So that's perfect. So everything's working. Now we just kind of create the UI and everything around it. All right, let's go ahead and throw together our UI. If we go to our sprites here, we can see we have a few different UI elements. We have a game over image, we have a play button, and of course we'll have an actual text component for our score. Let me switch back to our normal inspector here. And let's go ahead and right click on our hierarchy and let's go to UI, and I'm gonna create a text element first. This will be for our score. And before I do anything, I'm gonna actually change some of our canvas settings. So let's click our canvas game object. Let's find the canvas scaler component, and let's change our scale mode. I very rarely use the constant pixel size that's defaulted here. I'm going to change it to scale with screen size. This is going to be important to make sure our UI actually properly adapts to different screen sizes. And this is definitely important for mobile where it's, everyone's going to be on a slightly different screen size. And so you want to try to set your reference resolution around just generally what the target devices are. So if you're developing for mobile, a common mobile resolution is 640 by 960. For tablet, it might be 768 by 1024. And obviously, then if it's portrait or landscape, flip-flop those values. For me, I'm developing my game for desktop here, so I'm going to just set mine to 1920 by 1080. And then I'm going to match it with the height. What this does is it's going to compare the resolution of the game wherever it's being played. It's going to compare to our reference one here, and it's going to adapt or scale our canvas accordingly. And then in this case, I'm going to match it based on the height, because our UI is going to really just be vertically kind of up and down. So the height is going to have the biggest influence here. Sometimes you want it right in the middle. And in this case, I'm going to have it at 1. So let's go back to our text component here. I'm going to call this score. And let's reposition it to the center. It's really tiny right now and you can hardly see it. Let's center align it. Let's middle align it. Let's set it to overflow, because I don't really care about the actual width and height. The score if your score ends up being 9999999, I just want to make sure it always displays. So I'm going to set that to overflow. Set the color to be white. Let's position it towards the top. I'm going to anchor it to the top of the screen. Once again, this is important that you properly anchor things, so when your UI adapts to different screen sizes, it will still be positioned properly. So I'm going to anchor it to the top. Now, if I have the position at 0, you can see it's really small, as you might barely be able to see it, but it'll be at the very top middle there, because that's where we anchored it to. So I'm going to bring it down, of course, and say -100. Let's maybe set the default text to like 0. And obviously, let's make this way bigger. Now, one thing people often do is Unity's default like text component isn't the best. And sometimes you'll notice that the font is very blurry, which doesn't look very good. So sometimes people will make this font size really large, but then they'll scale it back from the actually transform here. And this still makes the font rendering really crisp, but still being sized appropriately. So I'm going to set our font size to 300, and I'm going to make this, a tenth of that, or I'm going to scale it back down 10 times. So that looks pretty good. Another thing I want to do is add a custom font. So let's go ahead and bring that into our project. It'll be available on GitHub just like the sprites were. Link in the description of the video. This time assets fonts, and this is just a free font that I found online that very well matches the style of the rest of our graphics. So we go ahead and create a new folder for fonts. Let's go ahead and drag that in, and now we can assign this to our text component there, and that looks a lot better. Let's see what else. One thing we might want to do is add a little outline just to match kind of, for example, our little Flappy Bird's got a little outline. So let's add an outline component. We can click the add component button here, search for outline. And let's change the distance because you can hardly see it. So we do a 12. If you remember, our sprites were designed at 24. So I'm going to do half of that. 12 and -12, that looks good. We're going to change the color, bump the alpha all the way up, and let's set the color to be the exact same color as our Flappy Bird's outline here. So we use a little color dropper to change that, and that looks a lot better. Looks pretty good. Yep, great. So there's our text component for our score. Let's go ahead and add our game over next. Sprites. Now we don't want to just drag this in here because it's going to create a sprite renderer, which is not what we want. We want an actual UI element. So we're going to right click our canvas, UI, image, and then we can assign the sprite here in the image component. Now obviously it's all stretched weird, so we can click the set native size, which is going to change our size to match the actual image. And let's position this. We're going to anchor this to the top as well. And I'm just going to change the Y to be maybe like -225. Yeah, that works pretty well. Let's call this game over. Okay, and let's add our play button. Now this one's an actual button that you can click. So let's go to UI button. Let's drag in our sprite to the image component. Let's click the set native size. And you might be able to see it, but there's a little text on it that says button. We don't actually want the text, so we can just go to that child game object and delete it. And let's go ahead and position this at the bottom this time. We're going to anchor to the bottom middle, and let's set the Y to be, I don't know, 200. I forget. Let me see what I set it on my other one. 275. Okay, 275. And once again, you might need to position these and scale these differently based on, you know, if you're developing for mobile or whatever. All right, that looks good. Let's call this play button. And I think that's it, actually. That is our entire UI elements. We just gotta hook them up to the rest of our game now. Okay, so let's hook up our UI to our actual scripts now. Let's go to our game manager. Let's open this up. And we need to get a reference to all these various UI elements so we can do different things with them. So let's create a public variable here for our text, for our score. Well, we need to import using Unity engine.ui. And then we can declare a text component here, text, and let's call the score text. Let's get a reference to our play button. And I'm just gonna, I could reference it as button, but you remember this object actually has multiple components. There's a button and an image. So I'm actually gonna reference it just as a game object so I get the thing as a whole. So we're just gonna say play button. And same thing for our game over. Although that one is just an image, maybe yours is different. Maybe there's multiple different components. I'm just gonna say game over. Yeah, just game over is fine. And then we also will need a reference to the player themselves. So we'll just get a reference to the player there. All right, so we need to hook all this up. We need like a proper, like, you know, game flow, like play game, you know, increase score, game over, replay, etc. So when our game first starts, we actually want it to be paused because we want them to hit the play button. So we're going to add our awake function here, and we'll come back to that, but let's add some various functions. Let's just add the functions we're going to need. We're going to need play. We're going to need pause. And then we have game over, and we have increase score. I think that's actually it. So when our game first starts, I'm going to pause it because we want to actually hit the play button first. And also, as a side note, I'm going to set our target frame rate to 60. I don't need the game to run any faster than 60 frames a second, so this isn't required, but I'm just going to make sure the game doesn't exceed that frame rate. Okay, so we hit pause as soon as the game starts. And in pause, what do we need to do? Well, we need to make sure our bird isn't moving, our pipes aren't moving or anything. And there's various scripts that are all doing different things. And one of the easiest ways we can do that in this game is just simply setting our time scale to 0. It's essentially pausing the game. It's freezing the game. Time is not going to update. And if time's not updating, that means our update functions aren't going to do anything, you know, because everything's multiplied by delta time. And so this is a very easy way in our case to just pause our game. Now, something else we do want to do is we still should disable the player because they check for input and do a number of things. So we should still disable the player. So we can just say player.enabled equals false. And that's really it for our pause. For our game over, what do we need to do? Well, we need to display our game over menu or those UI elements. So there's really two, which is of course the game over one. So we're going to set active to true. And then there's also the play button. We of course want to display the play button. So we're going to set that active to true. And then when you get a game over, we also want to pause the game. So we'll just call pause. All right, what else? Our increase score here. Our score is changing, but our text component isn't. So now we can actually access score text. .text equals score to string. To string. There we go. So this is converting our integer into a string, which will get displayed on that component. And finally, we just have our play function here. So what happens when you play the game? Well, we should reset our score to 0. And since we're changing our score, we need to update our text. So we can just same exact line of code. we should hide the play button. So we can set active false and hide the game over, the little game over image. So we'll set that to false. We need to set our timescale back to 1. So things start actually moving and happening. And we need to re-enable the player. So we're doing just the exact opposite of what we did in pause. So we're setting our player to be enabled. Okay, and then finally, what else? One thing we might want to do is just make sure all the pipes get destroyed, because there will still be pipes on the screen that that will just be sitting there, and when we play the game, we want to reset everything. So we'll just destroy all of them. One way we can do this is to declare an array of pipes here. And we can say find objects of type pipe, or yeah, the script is called pipes. Oh, that was confusing. So, oh yeah, no, that's all right. So find objects of type pipes. And then we can loop through that array and just destroy all those game objects that it finds in our scene. So standard for loop here, I equals 0, I is list pipes.length, I plus plus, very standard. And then we can say destroy pipes I. Now, I've seen this mistake people have made from some of my other videos. We don't just say destroy pipes I, because we're getting a reference to the component pipes. It's not the entire game object, it's just that one component. We want to make sure we're actually destroying the entire game object. So we're going to need to say dot game object. It's very important, otherwise you'll just be removing that one component. And I think that's it, honestly. We just need to call these functions. Well, we're already calling game over. We're already calling increase score. Pause happens respectively from the various functions. The only one that's missing now is play. And play should get called when we click our button. So let's show you how to do that. If you go to our play button object, find the button component, there's this on-click handler here. We can click the plus button, and then we can get a reference to a game object, and it allows us to call a function on that. Now, this is another mistake I've seen people make. You do not want to drag in the script itself here. If you drag in the script itself, there won't be anything to call. We want to drag in a reference to the game object in our scene. So drag that object in here, and there will be a lot more options. We can call functions on the game object, on the transform, and on our game manager. So game manager, play. And so now this play function that we created will get called whenever you click the button. Let's go ahead and test this out, see if everything's working. So game starts. Oh, I got an error. Oh, so I forgot to actually assign these references. I declared them, but I need to make sure I'm assigning all of these. Let's drag our player in, let's drag our score text in, let's drag our play button in, and our game over image in, and we're good there. Let's try again. Play. Game is frozen initially. I can't move. I'm pressing things, nothing's happening. We click play, the things go away. I start moving. My score is increasing. I hit the top of the thing, so I lost. I can play again. And there we go. So now we actually have a fully working game of Flappy Bird. Awesome. All right, so after a little bit of extra testing, I noticed 2 problems that we need to fix. Potentially 3. One is that we're not actually losing when we hit the ground. Nothing's actually happening. And that's just simply because we never added a box collider or any kind of collider to our ground. So we can go to our ground game object, box collider 2D, mark it as a trigger. It's already set as an obstacle, so I think that's all we need to do. Let's play the game. And there we go. Now when we hit the ground, we actually lose. So that's good. That's one problem fixed. The other problem is Flappy Bird does not reset its position upon playing again. So in our player script, we can add an on enable to reset the position. If you remember in our game manager, when the game starts, the player is enabled. When the game ends, the player is disabled. So when on enable is called in our player script, we can just reset the position. And we just need to reset the Y, just the Y value. So let's get whatever the current position is. transform that position, and let's set the Y back to 0, and then just reassign this back to our transform. And then I guess we should also reset our direction too. Our direction just, initially should be 0. So our direction can be vector3.0. And once update starts getting called, it'll obviously kick back in. So that should be another problem solved. Let's play it one more time. So I die, I play, and it resets. Now, if I go way up here and hit the pipe up there, reset, it starts back in the middle every time. So that's all good. The only other thing I sort of noticed, it's not a problem per se, but I noticed that the pipes tend to go more towards the bottom rather than the top. And potentially we want to just adjust the, spawn position here. So maybe I want my spawner position to be, maybe more one way than the other. But just the way they're spawned, kind of the way they're positioned, you might want to vary this. So potentially we want, it to be 2 and -1. It's really up to you. It doesn't matter necessarily. But with the value of 2, it'll allow it to go a little bit higher up because it's already reaching the bottom. We have our ground element here. So it doesn't need to go as much down as it needs to go up because there's a lot more empty space at the top. So we want to set our max height to be 2 to allow it to go up even more. Now, once again, that's all just preference and something you can play around with to change the difficulty of the game. But that is it. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel for more videos just like this one, and leave a comment recommending what you would like to see next. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including access to the unique assets that I develop. Link in the description of the video. Thank you for watching. See you in the next one.